Two of the fundamental settings for spectrum analyzers are resolution bandwidth and video bandwidth, called RBW and VBW. These settings have major impact on how signals are shown on screen. Anritsu handheld spectrum analyzers have default settings for resolution bandwidth and video bandwidth that are good for general signal viewing. For some signals, different settings are needed to be able to make measurements. You can use a wide RBW to get fast measurements at the expense of higher received noise and reduced frequency resolution, or you can use a narrower RBW with slower sweeps to reduce noise, get better frequency resolution, and increase sensitivity. Because you have the freedom to set the resolution bandwidth from 3 MHz all the way down to 1 Hz, you can make the trade-off that makes sense for your measurement. As the name implies, one of the chief reasons to use a narrow resolution bandwidth is to improve frequency resolution, the ability to separate multiple signals that are close together in frequency. In this sweep, the big signal at the center of the screen appears to be one signal. However, by going to a narrower span with a narrower resolution bandwidth, you can see that the big signal is actually multiple signals. There is a trade-off between sweep speed and resolution bandwidth selection. The wider the RBW, the faster the sweep. The video bandwidth filter can be used to smooth out variations on a measurement. This measurement is made using automatic settings. There is a signal at the marker position, but it is hard to be certain. With these automatic settings, the sweep takes 232 milliseconds. The RMS detector can also be used to smooth out the trace. It also reduces the noise floor by around 3 dB. In this case, RMS detection is best for measuring noise and digitally modulated signals. Peak detection with narrow video bandwidth is best when looking for low-level CW signals, such as spurious signals or low-level harmonics. This measurement was made using a narrow video bandwidth to clean up noise variations on the trace. Notice that the small signal at the marker position is easily seen with the narrow video bandwidth, and the sweep takes about 431 milliseconds. You can get just about the same results by averaging 20 traces, but it takes longer to get the results, about 2.3 seconds. You can also select a narrower resolution bandwidth, in this case taking about 1.3 seconds for the sweep. There is also a trade-off between sweep speed and video bandwidth selection, although it isn't nearly as dramatic as for resolution bandwidth. The default ratio of RBW to VBW is 3, meaning that the resolution bandwidth is 3 times the video bandwidth. You can change the ratio from 1 to 1 all the way to 3 million to 1. The higher the ratio, the narrower the video bandwidth for a given resolution bandwidth. With a ratio of 1 to 1, a 3 MHz resolution bandwidth gives you a 3 MHz video bandwidth, while a ratio of 3 million to 1 delivers a 1 Hz video bandwidth. Generally, doing that doesn't make much sense because the sweep speed would be very slow. With a 3 MHz resolution bandwidth, a ratio of 100 or 1000 to 1 is enough to filter out enough noise that the trace is very smooth and the sweep speed is still fast. Sometimes there are rules that must be followed when making measurements. When measuring an AM broadcast signal, the FCC rules in the United States require a 300 Hz resolution bandwidth and a wide video bandwidth, what they call no video filtering. With the flexibility of Anritsu handheld spectrum analyzers, measurements can be easily customized to achieve desired settings.